All right, 15D. Let's look at the sample mean of a normal distribution. So for a normal distribution, the prerequisite of this is you have looked at normal distribution in methods. So here we go. Let's start with, do you remember what we did before with a linear combination of two random variables? Now we're going to focus on a random variable that has which is distributed, has a mean of mu and a standard associated standard deviation. Let's respectively call x1 and x2. That represents the IQ of a person selected at random from this population, meaning they will also be normally distributed with the same features. The same with the second person, and um, as long as you have those two randomly selected, they are independent. And now we're going to consider the mean of those two persons. So the mean will be x1 plus x2 over 2, which is a linear combination. So we're going to do a little bit of manipulation that what we did in the previous exercise, which is we want to determine from that new variable x, we want to find its expected value and its standard deviation. So we apply the formula to determine the expected value and the variance. Both as you combine x1 and x2 as a sum, it's a linear combination. We can apply the rules that we've done before, and we end up with the expected value being the same and the variance being that one. We square root to get the standard deviation, which is we're gonna express this that way, okay? Which is 15 is the original standard deviation of the IQ random variable, and root 2, the 2 will relate to the number variable, which is 2 for this example. Hold on, was I doing that right? Yeah, okay. Whoops. So with this one, have a read, look at the question. So it's a direct application of what we've done before with two variables. Okay. So let's move on with that. So first, probability. Again, we need to, with normal distribution, we tend to standardize, and then we can determine either by hand because it's a whole number, or you can just cas it. Okay. Now we need to find the mean IQ of two randomly selected individuals, so it's two of them. Similarly to the proofing that we've done before, we end up with that random variable, that mean random variable will have the same mean, but the standard deviation will be 15 over root 2. We can, with those new parameters, that gives us a new normal distribution, we can standardize that probability. Once we standardize it, we simplify it. This one, we're going to use a calculator to evaluate it. Okay. So what we can summarize or comment from those two answers, the probability that the mean IQ of a sample of size 2 will be greater than 115 is going to be much smaller, which is this one, than the probability that one individual will have an IQ greater than 115. So that's how the comparison is outlined here. We'll generalize that. So we did a sum of two variables. What we can do now is generalize that for a sample of size n. So again, we start with a normal random variable with the respective mean and standard deviation. we'll get a sample of size n from the population. What it means is those n random variables will be independent, but they also will have the same distribution as the normal original random variable. The sample mean is defined as below, okay, which will have the same mean, but now the standard deviation will be sigma over root n. And what we can do is, for a particular value of that sample mean, which is annotated in lowercase, which would be just the sum of those values divided by n. So this is a summary of what we've done before. So the sample mean is also a normal distribution. It has the same mean as the original normal distribution, but now the standard deviation will be smaller. It will be over root of n, and n is defined as the sample size. So here we have a normal distribution, mean, standard deviation. Now we set up a sample mean with a distribution of a sample size 16. We get the same mean, but the standard deviation will be just the sigma over root n. We substitute the values and we get that new standard deviation for the sample mean. Alright, next one. Probably a good idea to pause it and just to practice how to standardize a normal distribution or a probability and apply the rule for the sample mean. So here, with the first one, find the probability that a woman chosen at random has a height greater than 168. So again, we're going to use the same features of example 10. We standardize that, which is greater than 1, and we get that that value. Now we get a sample of 4 women chosen at random, and that we need to find that probability for the average height being greater than 168. So this is the average relate to the sample mean. We have a sample size of 4. So what we need to do for is determine the new distribution of that sample mean. We'll have the same mean or expected value. That new standard deviation will be sigma over root n, which is 4. So now we want the probability of a average height being greater than 168. We standardize that using the expected value and the new standard deviation. We get probability of z is greater than 2, and you can cast it or use a the 3-part rule, but that is covered in methods. Okay, just use the CAS calculator, and that's pretty much it for this exercise, and I'll see you next time.